In this example, we are going to find the volume of a solid using the slicing method. The solid will have a base that is a circle of radius 9, and the cross sections, or the slices, are going to be perpendicular to the xy plane or to the circle, and each cross section is going to be a square. So to help you picture this, I'm going to draw one of the cross sections on here. So these 2 points that I just drew on that circle are going to be the corners of a square, which is one of the cross sections. So there's a cross section. So when we use the slicing method, we need to define the area of each cross section. Because this is a square, it makes it easier because all we need to do is find the length of one side and then square it to find the area. And just to make sure you're spatially aware of where we're at right now, here's the x-axis that I just highlighted in green. And this here is the y-axis. So when I plug in a value for x, I'm going to get 2 values for y. Let's write this down. So let me erase and make room. So the equation of the circle we have here, because it has a radius of 9 and a center of 0, 0, I have x squared plus y squared is equal to 81. That 81 is 9 squared. That's our radius squared. When I solve this for y so that I can plug in x and get out the value of y, I'm going to have plus or minus the square root of 81 minus x squared. The positive square root is the top half of the circle, so that will be the semicircle that is in the first and second quadrants. And then the negative square root will give me the bottom half of the circle that is in the third and the fourth quadrant. When I plug in a value for x, I'm going to get 2 different values of y. I'm going to get this point right here that I highlighted in pink and this point right here that I highlighted in pink. So that will give me 2 y values for the same x value. So rather than worrying about having 2 different y values, what I propose is you just look at the one y value. We'll use the positive square root. So we'll only look at this point right here. And so when I plug in that value of x, it gives me the corresponding value of y. That will give me the distance from the x-axis up to the point on the circle. Because a circle is symmetric, all we would have to do is double that value to find the entire length of the side of that square. So the length of the side of that square is going to be defined as the square root of 81 minus x squared, and then we have to double it, and then because that is the side of our square, to find the area, our a of x, we just square it since the sides are the same. So now what we need to do is integrate that over the interval of interest. So I'm going to integrate 2 times the square root of 81 minus x squared squared. And I just have to find my limits of integration. The interval that we're interested in is from -9 to +9 because the center is at 0, 0 and the radius is 9. This is what we need to calculate in order to find that volume.